Number 2, similar to number 1, the first thing that we need to decide is which of these are the wolf and which is the goat in this reaction. And so for this, we'll need to determine the oxidation numbers again. Recall that the oxidation number for oxygen is always 2. However, overall charge in the entire species must be -1. That means that our bromine's oxidation number must be +5. Because if we have 2, 4, 6 negative charges, we need the outcome to be -1, which means we have to add only 5. So the oxidative number for bromine is +5. And for all of our oxygens is -6. Hydrogen is always going to be +1 here. Iodine is a minus state here, so remember it gets the same oxidation number as its charge, so this is -1. I2 is the elemental state, and the elemental state, the oxidation number is 0. For bromine here, it has a minus charge, that means its oxidation number is -1. And for H2O, our oxygen is always -2, and we have 2 hydrogens, and that will be +2 to equal a charge of 0 for the overall species. So in this reaction, the bromine is the wolf because it's going from +5 to -1. That means it has to take in or gobble up 6 electrons in order to go from +5 to -1. And in this reaction, the iodide, or the iodine, is the goat as it changes from -1 to 0, meaning it provides 1 electron in the reaction. So now we have to balance it. For bromine, we need 6 electrons. One iodide is providing 1 electron. That means we need 6 of them. And that means we'll have on the other side 3 iodines because it's diprotic, meaning there's 2 in there. We need to next balance our water. So we can balance our oxygens first. I have 3 oxygens over on the reactant side, which means I'm going to have 3 over here. And lastly, we need to balance our hydrogens. I have 6 hydrogens on the product side because I've got 3 times 2 is 6. So I'll need 6 hydrogens over on the reactant side. And now our reaction is balanced.